Hi everybody, welcome back. In this video, we're going to show you a couple of ways to compare some of the common lamps and light sources. So let's start with the shape and size of different lamps. And this table from your textbook kind of goes into some of the wide variety of different lamps that are available. And did you know that these shapes and sizes can be incandescent, halogen, compact fluorescent, or LED? All right, we use some of the same descriptors for these lamps for the different types. I'm going to place some more resources in your module for you to learn about these different lamp shapes and sizes. Now, because of the technology used to produce the light, fluorescent lamps are a little bit different, all right? And they are most commonly in that straight tube shape, all right? And they typically have pins on the end. You can see kind of in the illustration here, and those are the connections rather than a screw type base. All right. That tube can be bent, and so you see that every now and then you get one that's a U shape or maybe even a circle shape. All right. The most common ones, like I've said, are the straight ones, and the T stands for tubular, and the number stands for the diameter of the tube, all right, in eighths of an inch. I didn't know this for a long time, but a T5 therefore has a diameter measuring across the tube of 5/8 of an inch. A T8, which is the other most common tube, has a diameter of 8/8 of an inch across the width of the tube and is therefore 1 inch wide. Let's move on to comparing light sources. So earlier you learned about the many different characteristics of light sources that we use to make our design selections. All right, in this section, we're going to narrow the focus in to three of the major characteristics, and that is, let me show you right here, efficacy measured in lumens per watt, remember, color rendering, CRI, okay, and remember that that is measured in comparison to our sunlight, our daylight. And finally, life. This is lifespan specifically of the lamp itself, and it's measured in hours. How many hours will you be able to use this lamp before it fails and you have to replace it? And although this chart is comparing many different types of light sources, let's narrow in, let's zoom in on the incandescent, fluorescent, and LED light sources that we've been talking about in this lecture. Taking a look first right here at the incandescent light source. You can see that it measures very low on the efficacy scale. All right, so this is higher to the right and lower, and the incandescent is the lowest efficacy light source. Moving over to color rendering index, you can see that one of the reasons that we very much like incandescent lights is that they have an excellent or very high color rendering index. Right? Now in lifespan, they are some of the worst. All right, you have to replace incandescent bulbs frequently, and you can see that they have a very low life. Moving on to fluorescent. Here's our fluorescent row right here. A fluorescent light source has a medium to high efficacy, and that's compared to the other light sources. All right. It has somewhere between a good and an excellent color rendering index. Now, as a designer, you need to keep an eye on this when you select your fluorescent light bulb. All right. If you're going to use it for indoor use, all right, and typically your ambient or your task lighting, you want excellent color rendering index, so you'll need to specify that. And the lifespan of a fluorescent light source is pretty good. All right, it's one of the higher or longer lifed options. Right? And so you can see why fluorescent is a very popular choice. Moving down to LEDs, here's our LEDs right here. And you can see that there's actually quite a range of efficacy. All right, and this is due to the wide variety of technology that's used to produce these LED lamps. And it's not a mature technology yet. We are still improving these types of light sources. Also, I've kind of circled this bar and just to let you know that the warm LEDs, the warm lights that we very often like to use for our indoor sources, are on the lower end of the efficacy spectrum for LEDs. All right. The cooler lights, 4000 Kelvin and above, are um, more efficient. All right. They have higher efficacy. When you move into the color rendering index, again, you have to keep very close eye on your specifications for these LEDs to make sure that you're selecting things on the higher end in the excellent CRI um, category. Finally, your life, all right? This variety, the fact that this is so wide is because LEDs are in many, many different types of housings and luminaires, all right? And so most of them are very long life, extremely long life, especially compared with the fluorescent, especially compared with the incandescent. All right. Some of them are on the shorter side, but even then, there's still a nice long life. All right. And that usually has to do with a specialty situation that they're placed in. All right. So now we've compared efficacy, color, and life for the three most common light sources. But let's focus in a little bit further on efficacy. I want you to take a look at these different light sources over time, all right? Because as you know, the technology changes. So in this graph right here, we have time along the bottom from 1930, 1950, 1990, 2010. You know that we're now well over in this section here, all right? And over here we have efficacy in lumens per watt. Right? So you know that the first light source to be invented was incandescent. It's off the chart over here to the left, but it is a mature technology. We haven't improved it very much. It's not going to be able to be improved, and so the efficacy is right here along the bottom of the chart. Right? It is the lowest efficacy light source. Now taking a look at fluorescent, it's the green line right here. Looks like it was invented here in the 1940s, and the technology has matured. We made some big gains here, and the efficacy is now pretty much set right here around 100 lumens per watt. All right. Now, LEDs are the dark green line, and you can see that they were invented much later. All right. And when they were invented, they were pretty low efficacy. They have rapidly improved, and we actually don't know where that mature technology is going to end up. Now, later in the course, we're going to be talking about some of our California Title 24 requirements. And one of them is called the JA8 requirement and requires that all permanently installed luminaires be greater than 45 lumens per watt efficacy. So where does that fall on these charts that we've just been looking at? Let's take a look at the left. I've drawn in a line here at 45. All right, so everything that's over to the right is allowed, is legal here in California. Everything over to the left is not. You can tell that incandescent is not allowed. Also, halogen. Many people like halogen lamps. They are also not allowed. Fluorescent, definitely allowed. LEDs, most of them definitely allowed. Yes, there are some out there that fall under this line, but mostly they are. Okay. Now over here on the right-hand side, I've placed that 45 efficacy right here, 45 lumens per watt. So everything higher than that is allowed by California Title 24. All right. You can see that incandescent and halogen fall under the requirement. Fluorescent and LED are allowed. All right, everybody, in this video, we just covered different shapes and sizes of the lamps and also compared some of the most important characteristics of the different light sources. Thank you.